Okay, let's pick up the video 2 here, picking up where we left off yesterday. Remember, we have a turbine that's on the exhaust side or the hot side of the turbo. Okay, it's connected to a shaft in the middle that turns a compressor on the cold side or intake side of the manifold. And keep in mind that these basically are spun in opposite directions. So if you look at the turbo, our fins are up this way on our turbine side of the housing. The fins are the other way on the compressor side, as is the flow through the turbo. So on this hot side, we're coming in and around this way to come out into our turbo here to spin it. The intake side is designed a lot the same, except it's the opposite direction because we're coming in and going around the other way. So it's reversed from one side to the other as far as design flow for it to operate. Okay, so this is a fixed geometry turbocharger, and that's what we used as turbos for a lot of years. So they worked really well for a stationary engine or something that ran at a constant speed. So generators, equipment, running a pump, some oil field application, things like that, where it ran at one speed. Because one of the problems with a fixed geometry is the area through the nozzle, which is where the exhaust comes into the turbine housing, and the overall area inside this turbine side here controls the velocity or how fast that this turbo spins. So it was problematic over a wider RPM range operation, because you could design a turbo that had a lot of low end, so a low RPM, a smaller area, spun the turbo faster. The turbo was more responsive at low RPMs, had more boost at low RPMs, and that was really good for like getting a truck moving, things like that. But it became problematic as RPMs and load increased and the amount of exhaust that had to flow through the engine increased, because then this could become a restriction and actually rob you of power and cause drivability problems. So early on, these fixed geometry ones had the problem of you didn't have very much takeoff. They would roll coal, a lot of black smoke out of them. It took the turbo a little bit to kick in. So it was almost like a two-stroke engine. If you've been around any dirt bikes or chainsaws or things that operated on a two-stroke cycle, low RPM, you don't have as much, and it has kind of like a power band that kicks in. So the old fixed geometries were that way because they would limit out at high RPMs and high loads. So you had to have a larger turbine wheel for that. I mean, the area inside the turbine and the nozzle. But at low RPMs, it was a problem because, like I said, it was like doggy. That was the complaint drivers would have. I have to step on it and it just kind of bogs out, and then slowly as the RPMs pick up, you feel the power kick in, and then high RPMs, it really has a whole lot of power, but low RPMs was just bad. Well, the problem with that is we roll a whole lot of unburnt fuel because we're giving it fuel, but not enough air yet to burn that. So that's called turbo lag. So the driver would complain of, I step on the pedal, it doesn't develop power quick enough, so it kind of bogs a little bit, or it's slow to develop power. So that was called turbo lag. Turbo lag's very bad for emissions, so we had to start getting rid of that. So you started seeing fixed geometry go away, and we had to get into a wastegated turbo, which will be another video section that we go through. But you don't find a lot of fixed geometry turbochargers anymore, especially on on-road vehicles, because of that emissions problem. So early on, to develop or not to help with this turbo lag problem, we had to do what's called spooling. And a lot of people say, well, that's when a turbo is really spinning fast, it's spooled up. That's not where that term came from. Spooling was a early on way to help with emissions and not have that bogging problem. We stepped the fuel slowly, and I say slowly, it still happened really fast, but instead of just you stepped on the pedal and it just started dumping fuel to make it go wide open, it gave it some fuel, let the turbo speed up, and then increased the fuel, let the turbo speed up, increased it, so it spooled or stepped the fueling up to prevent the turbo lag and the bad emissions. But that wasn't a real good plan. The engine accelerated a little slower, so then they came up with a wastegated, which helped with that. So fuel increased in proportionate steps is known as spooling. We'll pick up with another video on wastegating next.